Number 31, we are going to make a Venn diagram. That's that circle diagram. So let's do this and like this. Okay, 65% take AP Statistics, 45% take AP Calculus, 30% take both. I'm going to start with that. 30% take both. So this is Calculus, this is Statistics. 65 take Statistics, which means that's 0.35, meaning they could be in both classes. So 30% are in both classes, 35 only taking Statistics, 65 total. And then where is it? 45% take AP Calculus. Well, they could be in both classes. So we're going to say that 15% are just in Calculus. And you might say, well, that doesn't add up to 100%. Well, there's a group out here that doesn't take either class, like that. Okay, anyway, let's answer the question. So they're in AP Calculus or in AP Stats, but not in both. So not there. So we're just going to add those together, and what do we get? 50%. So C is the right answer for that one. Let's go to number 32. Number 32. Which of the following statements is true for a t distribution? Letter A, the t distribution and normal distribution are not related. No, that's false. They are related. The tails of the t distribution are lighter. No, they're heavier. So remember, the t distribution looks like this. So here's our normal distribution. And our t distribution might look like this. Remember, the area is still 1, but it's got fatter tails out there. That's a terrible drawing, but you know what I'm saying. So here's our t distribution. Here's our normal distribution. And the larger sample size we have for a t distribution, the closer we're going to approximate the normal distribution. Okay, so that's letter C. The t distribution approaches the normal distribution as the sample size increases. Right there. Let's go to 33. So number 33, remember, even though they're saying the difference, we never subtract. Okay, so these are going to be out. And we got to divide by the sample size, so this one's out. And we don't pool it. We're going to go with letter B. So that's the answer to that one, number 33. Let's go to 34. Number 34. So if we go from a 90%, so think of the graph like this, right? Here's 90%, and we're going to have an interval from here to here. Well, if we go to 95, we're going to have more of that data, so it's going to be wider. It's a wider interval. But, tricky, we can't number, it's letter E. We can't determine that, okay, just based on going from a 90 to a 95. So remember that. Let's go to number 35. Okay, so number 34. Now, if I was looking at I don't know if you noticed this, but lots of times when we look at a problem, if 3 are very similar and 2 are similar in a different way, a lot of times I just say, well, I know it's not that. So we're going to pick from these 3. Now, we're going to take what we expect versus what we saw from our sample. So that means that this one is out. And then, do we take the population proportion or the proportion of what we saw? And it's the population proportion. So the answer is going to be letter A. Okay, good thing to remember. So number 36 is we're going to consider the scatter plot below. So hold on for a second. Let's take a look at that scatter plot. Okay, we're going to check out this outlier in this least squared regression line. And let's take a look at it. So basically, when we take a look at a least squared regression line, how closely are these in a straight line? Okay, well, this one point is going to mess up our data, make it a little bit different, which means our correlation is going to be, if we took this out, imagine that was gone, well, now those points are all pretty much in a straight line. So it's going to increase our correlation. Now, if we take this out, what would happen if we drop that out of our, it's kind of like, think of it this way, this dot here is kind of pulling this data up a little bit, which is going to increase the slope. So if we get rid of that, it's going to drop the slope a little bit. Think of it as like a balloon pulling it up, I guess. Same thing with a weight. When there's an outlier on the downside, is pulling it down. So if you cut that weight off, it would rise up. That's the way I think about it. So if we got rid of it, the slope would decrease. It would lower a little bit, and the correlation would increase. Let's see which choice that is. Aha! Letter D says that about that stuff. Let's go to number 37. 37 we really can't do. That was from chapter 12. We just didn't have enough time to get there. So that happened. Let's go to number 38. Oh, by the way, if you just wanted to take a guess at it, the answer is D. Remember, don't leave any of them blank. Okay, let's go to number 38. So if you think about this question, number 38, 120 out of 250, so that's 48%, right? 48%. 120 divided by 250, plus or minus 3%. So we're thinking that it's somewhere between 45 and 51%. That's what we're thinking. Our true proportion is somewhere in between these two numbers. So it gives us a cushion, right? We're just estimating. That's what we do in statistics. Anyway, B is the one that's the most true. The true proportion of adults who would vote for the candidate is likely to be within 3 percentage points of the sample proportion. That's what we're saying right there. Okay, let's look at 39. Okay, so we have 15 students ranging from 2.25 to 5.5 years old. Suppose the youngest child in the class moves to another school and is replaced by a new student that is 6 years old. Which of the following statements, now don't forget, which one is false, which one is not true? Okay, so all of these are true except for one. So be careful when you read these questions. You've got to read them carefully. So these are kind of tricky, but the answer is E. If you take the youngest kid, right, and move, so you basically got rid of the youngest kid and added an oldest kid, right? So everything shifts up one. That median age is not going to be the same. It's going to move up one kid. Okay, so if you were struggling with this one, I would just write down the numbers, right? And maybe take a look at them if you really had a little bit of time to do that. So let's look at number 40. So I want to emphasize that in some of these, when you do get stuck, you can just use common sense. You guys have learned a lot, so you just have to relax and think about it. So you're studying fuel-efficient cars. So some of these don't really make sense. For instance, letter A. For each additional 1,000 pounds in car weight, the fuel efficiency will decrease by 48 miles per gallon. That doesn't make sense. For each additional 1,000 pounds in weight, the fuel efficiency will decrease by about 0.67, maybe. For each additional 1,000 pounds in weight, the fuel efficiency will decrease by about 8.2. For each 1,000 additional pounds in car weight, fuel efficiency will decrease by about this. Wow, all these. So we have to figure out which one makes sense. So when you look at this, these tables, so this is kind of like a least square regression line. So it's kind of like, what would you come out with? MPG, miles per gallon, would be negative 8.21 times the weight in thousands of pounds, plus 48.73. So it's kind of like an equation of a line. The miles per gallon is the weight times in thousands of pounds, okay? So for 1,000 pounds, it's going to decrease by that amount. We really just look at these two things. This is the y-intercept, and this is the slope of the line. So if we do that, you come out with letter C. For each 1,000 pounds of car weight, the fuel efficiency will decrease by 8.2.